All right. Good morning, everybody. Welcome to Monday, the 4th of October. Yep, Monday, October 4th. Um, let's see. Let's talk about Alex. First of all, how are you doing? Yeah, yeah, yeah. Let's talk about what's happening. Um, this week we're covering assignments 10, 11, and 12 on Monday, Wednesday, Friday. Next week I'm going to spend 2 days, or I've allowed 2 days for assignment 13. Monday and Wednesday next week we can talk about assignment 13. The next week is an SBC fall break on Friday, so we will not be having class next Friday. The following week, October 8th, the following week, week 8, beginning October 18th, is our exam 2 week. We'll spend Monday addressing any questions from the review or the homework. And like exam 1, we'll take 2 days to take exam 2. It'll come in 2 parts. And we'll spend Wednesday and Friday taking exam 2. Well, it just seems like the other day we did exam 1. We're already getting close to exam 2. So I have no other announcements for today. So at this point, I'm just opening up the floor to you. How can I help you with any questions that you have over assignment 10 or any other questions?
Can we go over question 10?
Yes. Do we need to go over the whole thing?
I'm sorry?
Over all of it? The whole thing?
Yes, sir.
Okay. You're given the standard form of a circle, the equation of a circle, and we want to address some of the following questions. So, these questions that come after this all depend on us being able to, one, compare this to the standard form x minus h quantity squared plus a y minus k quantity squared is equal to r squared, where our center is hk and the radius is r. So we're going to compare this equation to the general standard form so that we can derive the center and the radius. So part A asks for the radius. So 81 is equal to r squared. If 81 is equal to r squared, then that means that r is equal to, well, what squared makes 81? 9. Radius is 9. B, we want the center. So, if we say that y minus 2 quantity squared is equal to y minus k quantity squared, then that means that rk is equal to 2. Notice that you have y minus, so you have y minus, and then the k has to be 2. Now, for the, what is it, x, oh, come on, iPad. Sometimes it just likes to freeze up on me. Okay, back in business. Now, for the, what is it, y plus 3? Or x plus 3, excuse me. If that's equal to x minus h quantity squared, what we need to do is, because I don't have that minus sign right here, I can rewrite this as x minus a negative 3, which then means that my k is equal to negative 3. So, excuse me, my h is equal to a negative 3. So, pulling this information together, we get our center is at negative 3, 2. Now, in the notes I briefly said something like this. The easy way to do this is to think about opposites. So, what's the opposite of positive 3? Negative 3. What's the opposite of negative 2? It's positive 2. And here's why we can think about the opposite. It's all dealing with this comparison of this equation to our standard form. Then it asks us to graph the function. So in the last class I didn't do this very well, so I'm going to do a better job here. That should be enough, I hope. We're about to find out. Alright, so first of all, I have a center at negative 3, 2. So there's my center. And since my radius is 9, we're going to go 9 units up, to the left, down, and to the right, or up, right, left, or down, left. We're going to go 9 units in every direction. So if I go 9 units up, I'm just going to stay at negative 3, but I got to go up. 9 plus 2 is going to be 11. So we have 2, 3, 4, 5, 6, 7, 9, 10, 11. Just enough. So I'm now at the point negative 3, 11. Then I'm going to go 9 units to the right. So negative 3 plus 9 is going to get me at positive 6. 1, 2, 3, 4, 5, 6. plot a point. So now I'm at 6, 2. And then I'm going to go 9 units down. So 2 minus 9 is going to get me to negative 7. 2, 3, 4, 5, 6, negative 7. Plot that point, so now we're at negative 3, negative 7. Negative 7. And then I need to go 9 units to the left. So negative 3, 9 units to the right is going to get me to negative 12. So 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And so now we're at the point negative 12, 2. Well, I don't have any. I wish I had some shape things I could make shapes with on this, but I don't. So we're just going to give it our best shot. Sometimes you just keep going around and around, you'll eventually get there. We'll call that close enough for our purposes. There's our circle. There is our circle. Alright, so D asked the question, is this a function? You tell me, yes or no. Why not? Doesn't pass the vertical line test. Very good. You draw a vertical line, and a vertical line that goes through the circle will turn the circle at 2 places, so it's not a function. E is asking for the domain. So it's asking for the domain of the relation. So domain is the set of x values that are represented on this graph. So we need to go, if we think about the set of x values, we need to think about all these x values that are between negative 12 and 6. And to express all those x values between negative 12 and 6, we just say negative 12 to 6 brackets. So don't say, I often get this, negative 12, negative 11, negative 10, blah, 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 3, 4, 5, 6. Don't do that, because you're missing all the fractional values. You're missing all the values in between those digits. So we have to express all of them using interval notation. F, what is the range? So when it comes to the range, we need to talk about all the y values that are on this graph. So what are all these y values on this graph? Well, the y values go from negative 7 all the way up to 11. So what's the range? We're doing that in red. Negative 7 to 11. And there is problem number 10. Does that make sense? Okay. Good. What else can we look at?
15.
What number was that?
15.
15? Find the equation of the circle. Now when it says find the equation of the circle, that means we want x minus h quantity squared plus y minus k quantity squared equals r squared. Find the equation of the circle with the center at the origin, and it's going through the point contains the point for -2. Okay, so let's just get a picture and think about what's happening here. We know that we have a circle whose center is at the origin. So we have a circle, and it's going through the point 4, -2. Now, I can roughly guess where 4, -2 is. I'm just going to maybe put it right here. There's the point 4, -2. Now, this is just a rough sketch of the circle. So, what does this equation need? It needs two things. It needs a center, and it needs a radius. Well, we know what the center is. There's our center. It's given to us. The center is at the point 0, 0. So when it comes to the equation of the circle, we can start to get some information in. We can start to say things like x minus 0 quantity squared plus a y minus 0 quantity squared. Now, the next thing that we need is the radius. Now, we have the center. We have a point on the circle. So the distance from the center to any point on the circle, this distance is r. Now, it doesn't tell me what r is, but I can find out what r is using the coordinates that they give us. So here's the idea that you want to do. You want to create a triangle, and more specifically, this is a right triangle. Now, because we're going through the point 4, -2, the length of this right triangle is going to be 4, because that's the x-coordinate of the vertex. The height of this triangle, we're just going to call it 2, because the y-coordinate of the vertex goes down here to -2, so we'll just call this 2. So we have a triangle, a right triangle, where we have a length of 4, a height of 2, and we're going to use the Pythagorean theorem to find out what r is. We know by the Pythagorean theorem that r is equal to x squared plus y squared. So that's going to be our 4 squared plus our 2 squared. And you can see why here, even if you put -2 in here, it's still going to give you a positive value. So that becomes 16 plus 4 is equal to r squared. So r squared is equal to 20. But that's great. That tells me what r squared is. Well, I mean, if you want to take a full step further, you can say that r is equal to the square root of 20. So now you know what r is. Now we're going to fill in the rest of our information. Is equal to square root of 20 squared that we're just creating this equation up here. So at this point we can give our final answer. I'm just going to rotate my screen like this. So we have x minus 0 quantity squared, that's just going to be x squared. Y minus 0 quantity squared, that's going to be y squared, is equal to the square root of 20 squared is 20. And there's our equation of the circle. X squared plus y squared equals 20. There is the equation of the circle, whose center is at the origin and it's going through this point right here. Does that make sense? Cool. What else can we look at?
Three.
Say that one more time, please. 3?
3.
We want to find the distance. Find the distance of the line segment that has these endpoints. So, a couple of things that we got to know. We got to know our distance formula. Distance is x2 minus x1 quantity squared plus y2 minus y1 quantity squared. This is a derivation of the Pythagorean theorem. So this is a plug-and-play operation. We're going to plug in values. But before I just go plug in values, I'll always like to name my coordinates so that I don't mess things up. So this is just a matter of plugging things in. Now, you're probably looking at this and saying, oh no, I got fractions. I don't like working with fractions. Well, things are going to work out so nicely here. Things are going to work out so nicely for us. If you haven't done this problem, you're going to be surprised about how nicely things work out. x2 minus x1, so negative 1/4 minus 3/4. Now, what do you notice that's nice about this? Why is this going to be easy to do? What makes this easy to do, this operation right here? How do we add fractions together? What must be true for fractions?
They have the same denominator.
Yes, that's going to make our work really nice. Plus, and look, we end up with the same situation when we're dealing with our y's. Negative 1/7 minus 6/7. Same denominator. So we don't have to do a whole lot of work here to combine these together. So let's keep going. Negative, excuse me, negative 1/4 minus 3/4, that's going to be negative 1 minus 3, that's going to be negative 4/4 quantity squared. Negative 1/7 minus 6/7, negative 1 minus 6 is going to be negative 7/7 quantity squared. Okay, what's negative 4/4? 1. Specifically, it's a negative 1. What's negative 7/7? Negative 1. What's negative 1 squared? 1. What's 1 plus 1? 2. It's a nice little problem. Here's what this problem entails. You have to know one thing. I've already mentioned we have an exam coming up. You have to know this. You have to know this formula. Have to know that formula, and the purpose of this is, can we plug things in correctly into the formula, and can we simplify? So, I don't see myself giving you fractions in here where you have to go through and find a common denominator and rewrite stuff. I mean, maybe if I just have a really bad night and feel like I gotta write that problem down. But this is really straightforward because it simplifies nicely. Maybe you end up with some fractions down here, but everything will work out nicely. We like nice answers. We like things that end up nicely like this. Alright, anyways. What else can we look at?
$16?
60. Or, you mean 16?
Yeah, 16.
Alright. Now, I feel like you need to do this problem. So I'm just going to get you thinking about it. I feel like you need to do this problem, so I'm just going to get you thinking about it. Find the equation of the circle with endpoints of 2, 3, and -4, -5. So I'm going to take a quick second to hopefully get a decent sketch of this graph. Two, 3, 1, 2, up 3. -4, 5. 1, 2, 3, -4. So that's 2, 3, -4, -5. 1, 2, 3, 4, 5, negative. Alright, so here's our endpoints. And what we have is we have a circle where this is the diameter. So, I mean, this is not going to be the prettiest looking circle, but alright, so this is the picture. Now, I mean, you can clearly see that the center is not at the origin. Number one, this line does not pass through the origin. And even though I sketched it out on this grid, I mean, I could give you a problem where, you know, we might be able to say, oh, it's right here at this point right here, but we don't know that exactly. We don't know anything exactly by this picture. So what we got to do is we got to start finding out information. So when it comes to our equation, x minus h quantity squared plus a y minus k quantity squared equals r squared, we need two things. We need a center. And the center is going to be at HK. And we need a radius, which is going to be R. So let's talk about the center. We're given this line segment, the diameter. And we know what the endpoints are of this diameter. We know that we're going to 2, 3, and -4, 5. Now, what do we know about circles, diameters, and radii, or centers? We know that if you take the diameter and find its midpoint, that is going to be the center. So, again, based upon my picture, it looks like you could say, oh, the center is at -1, -1. Okay, fine. But you don't know that exactly. You don't know that that's exactly true. It could be at -1.2 and -1.35. We don't know that exactly. So we got to find this exactly. So how am I going to go through and find the center? I'm going to find the midpoint of my endpoints, 2, 3, and -4, -5. I'm going to find the midpoint. Now, we've talked about midpoint. Midpoint formula, we have x1 plus x2 over 2, comma, y1 plus y2 over 2. There's our midpoint formula. So you're going to use these points, and you're going to use the midpoint formula, and that midpoint is going to tell you what the center is of the circle. And that's going to give you your h to the k. Now, what else do we need for this equation? We also need, what color do I want to use? Let's use blue. We also need the radius. We also need the radius. Now, there's a couple of ways to find the radius. Without knowing what the center is, R is going to be equal to my diameter divided by 2. If I know what the length is of my diameter and divided by 2, that's going to be my radius. So that means I could find the distance from this 2, 3 to -4, -5 and divide that by 2, and that will give me my radius. So, I want you to do this problem, but I want to, number one, ask the question, does this plan make sense? The plan makes sense? Good. So, you can go through and execute the plan. So this is a very common question. Very common question. I'm going to give you 2 points. I'm going to give you 2 points, and I'm going to ask you to find the equation of the circle. So, sketch it out. It doesn't have to be exact like I did. You can just roughly sketch this out, and you can start thinking about this. All right. If I'm given 2 points that form the diameter, the midpoint of those 2 points is going to be my center. And then I could use my distance formula, find the distance between these 2 points, divide that by 2, and that will tell me what the length is of my radius. And then it's just a matter of plugging everything back up in here into this equation. All right. What else can we look at? Pounding your fist on the table. I saw someone doing it. That's all Alright, what else can we look at? Four? Find the distance the points, 2 root 3, root 6, and negative root 3, 5 root 6. So we're going to plug into our distance formula. X2 minus x1 squared plus y2 minus y1 squared. And before I do anything, I'm going to label my points. And again, much like problem number 3, things are going to work out nicely for us because we're going to be combining like terms together. Let's see, I miswrote this as a negative root 3. Alright, there we go. Negative root 3 minus 2 root 3, quantity squared, plus 5 root 6 minus root 6, quantity squared. And we're going to combine these just like if you're combining negative 3x and a negative 2x together. Negative 3x and a negative 2x would make a negative 4x, right? So instead of doing x's though, we're doing root 3's. So we have negative 4 root 3 quantity squared. Same thing here. If you were doing 5x minus 1x, that would be 4x. So, but instead of x's, we're dealing with root 6's. So 5 root 6 minus 1 root 6 is 4 root 6. Alright, so quick little, with me so far? Everybody good? Thumbs up, thumbs down? So, next little thought that we got to be aware of is if you have a times b to x power of 2, this becomes a squared times b squared. A squared times b squared. So, when I apply these exponents, these squares, these exponents of 2's, I end up with a negative 4 squared times a root 3 squared plus a 4 squared times a root 6 squared. Hold on. I knew something was different. I knew something was wrong. Negative 1 minus 2 is a negative 3. Duh, Mr. Clopton. There you go. That's better. There we go. So negative 3 squared is going to be 9. Root 3 times 3 is 3. 4 squared is 16. Root 6 squared is 6. 9 times 3 is 27. 16 times 6 is going to be a 96. And then, here's what the way I do this in my head is I turn that 96 into 100. So 100 plus 27 is 127. But I got to subtract 4 from 100 to get 96. So I'm going to subtract 4 from 127, and that gives me 123. And root 123 does not simplify, and we're done. Alright, does that make sense? What else can we look at? We have maybe 3 more minutes.
Mr. Clopton.
Yes, ma'am.
Okay, so I started finishing 16, the one we just did, and I got stuck on writing the equation. Do you want us to square it, like, once we get it into the format of the equation?
So let me ask you a question. So we're looking at problem number 16. So I'm going to go back to that. I'm going to ask you some questions. Number 1, what did you get for H and K?
-4 and positive, or -4 and 4.
For H and K? -4 and 4? No. No. Think about it. -4 and 4, that would be -4, 4 would be up here. Midpoint. You should do 2 plus a -4 over 2. 2 plus a -4 over 2.
Your conference is scheduled to end in 2 minutes.
That's going to be a -2 over 2, which is going to be a -1. And this is a -5, by the way. And then 3 plus the -5 is going to be -2 over 2. It's going to give you -1. Do you see that? Yeah? What'd you get for your radius? What did you get for your radius? Please answer the question. What did
I got, cause you said the distance divided by 2, and I got 5.
Good. So plug in these values into your point right here. Do not square this, but square the 5. Shoot me an email if you don't get the answer. Okay? Alright. I will see y'all on Wednesday where we pick
Your
up
conference
with
is now over. Goodbye.
combination and composition of functions. See y'all on Wednesday. Bye.